Okay, so we're going to look into data validation and verification. Well, you're going to look into verification, and we're going to discuss data validation. So data integrity is important for many reasons, as we discussed last lesson that you would have investigated. But data validation and verification, when in use, the integrity can almost be guaranteed in a database, and it will significantly reduce the chance of human error. Now, thinking about the term validation, it can be slightly misleading because validation is almost kind of an untruth, really, because if we look at certain entries that go into a database, like a person's name can differ in spelling. There's many names, there's unlimited names around the world. You know, there's almost new names coming out every year. Some names are very common, okay, but it's far too complex to validate, far too complex. So if we think about types of validations that we can perform in databases, such as format or type or ranges, okay, that we can guarantee the integrity of those entries, and we can almost guarantee a complete reduction in human error. So examples of validations are presence check, so this ensures that fields are not left blank. Format check, where the date may have to be in a form of 2 digits for the day, such as the 28th, 2 digits for a month, which would be like, say, June, could be 06, and 4 digits for the year. So such as your date of birth might be 1994, so that would be 1994. Okay, length check, where we can check that, we cannot guarantee that an entry of a phone number is going to be inaccurate, but we can, reduce the error by making sure that the length is correct. A range check, where we can make sure that the data does not exceed 12, okay, because there's not 13, months in a year. A type check, where the numeric value for a date has to be true. Like you can check, for example, that there's 31 days entered, or some months are shorter, like there might be 28 days in February. Now here's an example of a presence check. So when you enter in a Contact Us form, you can see that the entries here, where the stars are, like little asterisks, have to be complete. So if you went to submit the form, then it will say check the form, and for example, they might highlight these fields here in red, okay? And for the email address, which is even more impressive, they will make sure, for example, they've got the @ in there, okay? So it has to be an email address, so it has to be, say, something like ICT with Miss Price @gmail.com, okay? So they would make sure that the @ is there. Other examples, like here, we've got the range checks. So this is where they could be used in a database, for example. Like if you was to fill out an opinion poll here, they will want to make sure that you are 18 or above. Number of students in a class, okay, so it has to be equal to or greater than 5, and it has to be equal to or less than 28, okay? So if you was to try and put in 29 students or 4 students, then that class can't go ahead. And the same with grades. Now you can see here it's less than F. Now the reason for that is obviously the highest grade is an A. So these letters will represent a valid grade must be less than F. Okay, so if they wanted to enter a course or something. So if they've got anything like, less than an E, okay, then they can't go in. But if they've got, say, for example, in terms of the database, anything greater than an F is just not accepted. So, like if they've got a U. Okay. Now, another validation check that goes through is this is a train ticket from England. Now, this train ticket here will say, for example, it will do a check very quickly. Now, a human can check all of these things, but obviously it takes time. So if you used to put the ticket through the ticket barrier, it will check your ticket in a second. And this is what the computer will do in literally 1 second. It will check the date. So if this person is using the ticket before the 1st of January 2014, then it will not let them through. Okay, or if it's using it, say, the 1st of January in 2015, it will not let them through. But anything on or inside those boundaries, the user can go through the gate. Then, before it will let the user through the gate, it will check that they're within any route of those stations. Okay, so the computer will do all those things, those validation checks very, very quickly. Okay, so hopefully that makes things a little bit clearer in terms of validation before we move on to parity checking. So, to begin with, we are going to discuss what is parity checking. Now, this is an agreed method sent by the computers where they will agree to how the data is transmitted, and they use the parity checking to check whether the data has been sent correctly, or if it's corrupt, or if it has been changed. So they need to see if the data has been transmitted and whether it's been changed or corrupted. So this could be over a large distance, or it could be over a short distance, like maybe going from, your computer to the printer and so on. So the byte of data is allocated a parity bit. Now that parity bit will determine whether there's going to be the agreement is going to be odd or if it's going to be even. And I'll discuss this with you further now. So the parity bits will be allocated prior to the transmission. And as I said, they will be even or they will be odd. So, does the data have, for example, an odd amount of number ones or an even amount of number ones? And it's all decided by the parity bit, which is at the beginning right here. So if there's an odd agreement, we are going to need an odd number of ones in. So you can see here that in this byte of data here, you can see there's number 1, 2, 3 and 4. So this would be at the moment odd. But if the computers agree to an odd transmission, then the parity bit here would be a number 1. But if they agree to an even transmission, then the parity bit here will be 0. So here's an example of an even transmission where you can see there's 1, 2, 3, 4 bits. So for example, that is obviously an even parity agreement. And here is an example of an odd parity agreement, because you can see, so I've lost my mouse, 1, 2, 3, 4, 5. So the even parity agreed here. So here's the two computers, and the two computers have agreed to an even parity. So you can see there's 4 number ones. So hopefully you've said, well, what's going to go in there is 0. Then you would be correct. Here is an odd parity agreement. So you can see there is at the moment 4 number ones in here. So that would be at the moment even. And we would put 1 in there to make it an odd agreement, which is very simple. Now, what if the parity doesn't match? Well, that can be a problem. So if the parity doesn't match, then the data is simply going to be resent, because at the moment we believe it may have been changed or it's corrupted, and it simply cannot be trusted. So therefore it's not sent. Now, although this is a very simple and straightforward method that seems almost fail-safe, the parity agreement isn't exactly perfect, because it's all you're basing it on is a whole bunch of ones and a whole bunch of zeros, and that can be a problem. So if you're just sitting there thinking, well, okay, if there's a bunch of ones that, you know, it's odd, then that's fine, it can go through. That one's even, it can go through. As long as it's met with the agreed method, the agreed parity, then the data will go through. So the sender here has sent a pattern of data. There's an odd parity check. So it's got 3 ones, 1 0, 2 ones, then 2 zeros. The receiver has received the data, and the data has got 3 ones, 1 0, 1 0, 1 0. Now, that will have gone through, and it would have passed the check because it was an odd parity. However, you can see here the order of the data has been changed, so therefore the data is still likely to be corrupt no matter what. So although parity checking is a very simple, very quick way for the transmissions, it's not perfect. Parity blocks. So parity blocks, these are blocks of data that can be easily comparable. So they're very straightforward, very clever. And you can see here is an odd parity agreement. Now, how you check this is quite simple. And how you can fix the error is really simple as well. So, our columns here have to be odd, okay? And so do the rows. So if I look at the first column here, bit 1, you can see it's 1, 2, 3, 4, 5 ones. Perfect. Okay? It's an odd agreement, so we need the odd numbers. In here you've got 1, 2, 3, 4, 5, 6. 6 is an even number. So we already know quite early on that this agreement is not going to go through. Now the trouble is we're going to have to check the other columns. Then we've got to check the rows. So like if I check the row here, you can see 1, 2, 3, that's fine. 1, 2, 3, 4, 5, that's fine. So you can see this is going to take a considerable amount of time for us to actually find what the error is. So we're going to need to literally narrow it down to, we know that this column here, this row here, okay, after we have to check the rows, has got a problem. And the same as this column. But the good thing is, we've narrowed it down to this 0 here. And all we've got to do to fix it is change that 0 to a 1 to make our odd parity agreement, which is quite simple, but, you know, probably time consuming for the computer and time consuming for the processor. So, automatic repeat requests. This is our next data that we're going to move on to, and this is very straightforward. Sorry, our next error checking method, I mean. So, it's also known as ARQ, okay, meaning so the Q you got request, but the Q can also stand for query. So sometimes it's known as automatic repeat query. This is a very, very straightforward method check, okay, so error method check. This is very straightforward. So obviously for GCSE, you only need to know what it is and to be able to identify it, but for A level, we're going to have to go into more detail. But for GCSE, this is what we need to know. So it's a method used to check data that has been transmitted correctly. Of course, that's what we do all the error checks for. We need to know, is this transmitted correctly? Now the sender will send a message, for example, and then the receiver needs to actually send an acknowledgement back to say that the data has been received correctly. So this is known simply as an acknowledgement. If after a certain amount of time the acknowledgement hasn't been received, then a timeout will occur and the data has to be resent. So here's a very simple breakdown. You've got two computers, one's the sender and one is the receiver. The data's sent, it's been received correctly, so an acknowledgement goes back to the sender. So If the data is sent again and you, basically they don't receive any acknowledgement, then a timeout may occur. So therefore the data will simply be resent. And then an acknowledgement will go back to say that yes, this time I've actually received the data. It's all very straightforward, and that's pretty much all you need to know on that one. So now we're going to move on to our next error check. Thank you for watching. Please subscribe to my channel, like my videos, teachers visit my shop on TESS, and follow me on Twitter. Very best of luck to you.